Again, welcome to Unit 2, Part 1 lectures. This is Python programming. In this section, we are going to learn about the basic concept of Python. First, we start with designing a program, what is input, processing, and also what is output. Also displaying output with print function. We're going to talk about what is comment, variables, how to read an input from a keyboard, performing calculations. So basically, we're going to learn the syntax of arithmetic operations using the Python, and also how to display an output result. So the first thing is designing a program. And as we all know from the previous lectures, we discussed that again, writing a program takes a lot of time, especially if you are going to write a very compressed and a large program. We cannot just directly start to write the code. We need to analyze the problem that we want to solve with the programming language. And also we need to know the steps, the tasks that we have to perform in order to solve. There are so many activities maybe to perform in order to solve one specific problem. So designing, in this course, most of the time, the code that we will go through is a very short code. So most likely we don't need to really design the program. Or example is, let's say I'm trying to write a program to find the sum of two numbers. I don't need to follow all the steps like designing the program, what are the requirements, because this is a very simple problem. So programs must be designed before they are written. It's very important. And in software engineering, we learn these techniques. The common technique is called the waterfall model. There are some 4 steps we follow in order to develop a program. First is that we need to analyze the problem. So this is the first stage called the requirement analysis. We have 2 types of requirement, functional requirement and also non-functional requirement. Functional requirements are the activities that the program will perform or the task. And non-functional requirement will be the quality of the software. For example, are we going to consider security of the program, the software, or we are going to consider the user friendliness or robustness of the system, etc. So there are so many, in software engineering, there are so many attributes that we have to consider. So those are the requirements, again, functional and non-functional requirements. Then the second step, if we're able to get all these requirements, this means we know what to be the input of the program and we know what to be the output. So the next step is to design the program. Designing the program, we can write the algorithms. The simple tools we will go through here is using what we call the pseudocode or the flowchart diagram. So after we design the program, then the next stage is where we write the code. When we write a code, most likely we may make some error, so we have to correct our errors. Then we test the program. If there's any error again, we have to again correct those errors. So those are again a very straight process or very simple process in again developing a software or writing a program. So here we said design is the most important part of the program development cycle. So what we just went through is called the development cycle. Always, most of the time we use the term software development cycle. First, I start the requirement to analyze the problem. What is the input? What is the output? What are the functional and non-functional requirements? Then the next step, I'm going to design. The design is to understand how I can convert the input to output. Then the next step, again, is writing the code, testing the code. If there's error, we need to fix it. Now, the reason why we said design is the most important part of the program development cycle is that if we design the problem and we were wrong, then automatically the whole program will be wrong. We will not get a solution. And most of the time, we even say that the requirement phase is also most important step. because here, this is where we ask the users or the customers what they want their system to do for them. So now, if the requirement we get from the customers, we didn't understand or it wasn't correctly stated very well, automatically, again, we are not going to get a correct solution after we develop the program. So understanding the tasks that the program is to perform is very important. Most of the time, software engineers work with the customers to get a sense what the program is supposed to do, ask questions about the program details, create one or more software requirements. Sometimes also, we may create a prototype of the system and then let the customer test it. If it's good, then we go ahead. If not, then we have to modify it. So determine the step that must be taken to perform the task, very important. One of the most common techniques we use is called a breakdown and decomposing the system. So for example, I have a problem. The problem is very complex and large. The best solution is to break the problem into smaller pieces. Solve each individual, then later we integrate the whole solution together as one unit. So breakdown require tasks into series of steps. We need to create our algorithm, listing the logical step that must be taken. Algorithm is a step-by-step, step by step. And also you have to be in sequential order, which means first task must be listed first, second must be listed second. So algorithm is step-by-step, step that again, we are going to use to solve a problem in sequential order. So here we use the set of well-defined logical steps that must be taken to perform a task. Most important, all the tasks must be in order, sequential order. So one of the techniques we use to develop our algorithm is called a pseudocode. Pseudocode also can stand for fake code, which means I can use any language, English, Spanish, any language, to write the program. In this case, I'm going to write the steps to solve the problem. Later, we can convert this pseudocode into actual Python program. So this is called informal language that has no syntax rule. It's not Python. Not meant to be compiled. It can be any language, English, Spanish, or executed. Also used to create a model program. We don't need to worry about the syntax errors. That in lecture 1, we say syntax errors are the grammatical errors. So we don't need to worry about the rules and regulations of Python language. Here we focus on the program design. Later we can translate it into the actual Python code. Also we can use what we call the flowchart. Normally a flowchart is a diagram that graphically shows the steps to solve a problem. So it's almost same as algorithm. In an algorithm using pseudocode, we are writing the steps in English. Now, flowchart is also the display of the algorithm, but this time we are using a chart, a diagram. And the diagrams also have to be step by step in sequential order. So, for example, we have a symbol. Ovals are for the terminal symbols. Parallelograms can be used as input and output symbols. Rectangles are the processing. And also symbols are connected by arrows to represent the direction of a flow of the program. And we will see an example. So this is a very good example. This is a flowchart for the pay calculating program. So here we start first. So our starting program, we need an input, and we said the input symbol is parallelogram. So we can see input symbol. And here we have to say what we are inputting. We are inputting the hours work. We need a second input, so we have a second parallelogram again. This time we are inputting the hourly pay rate. This program will calculate the pay of employees or the salary of employees. So I need input of number of hours the employee work, the employee hourly rate. If I know these two, then I can do my process. So we can see the rectangle is the process. So calculate the gross pay. Then the gross pay will be the number of hours worked times the hourly rate. So again, over is start and end of the program will be at the over symbol. Our input is parallelogram, so we need two inputs. Our process calculations is a rectangle, and our output also is a parallelogram, so display the gross pay after we calculate it. So we can see that again, this is same as a pseudocode. Step by step, we need first input, second input. We cannot calculate first before we ask for an input. We need the input before, because we have to use the input for the calculations. So that's the input, processing, and output. And we say typically computer perform these three steps, unless maybe we are using conditional statement or some other method to direct or to change the flow of the program. But normally, computer, first of all, need an input. It processes the input, then it gives us an output. So input can be any data that the program receives while it is running. Input, again, is any data that the program receives while it is running. Then from there, we perform some process on the input, and we get our result as an output. Now, process most of the time will be a mathematical operations or logical operations also. So displaying the output with Python, we use the function named print. So a print is a function. And what is a function? A function is a piece of pre-written code that performs an operation. So in Python and almost every programming language, we always have a built-in function, which we call the library files. So Python print function is a built-in function in the system. I don't have to write the function print in order to display a result on the screen. So function will have something we call the argument. Argument are what the function will use. So I'll say argument is like a message or data that the function need to use in order to perform its tasks. Statement is in a program execute in the order that they appear. So normally a statement execute top down. We say top down flow. Always execution start from the top down. Also, we have what we call the strings and also string literals. String normally is a sequence of characters, and not only characters, also symbol or values, but they have to be in double quotation or single quote. So string is a sequence of characters that is used as a data. And a string literal is a string that appears in actual code of the program. Always must be enclosed in a single or double quotation mark. So a string can be Charles, it can be a word, like say Charles, William, St. John's, etc. They have to be in double quotation. In comment, good news with programming is almost every programming language have a comment. A comment always will explain your code. The most common comment we always write is the name of the, excuse me, the name of the programmer or the date the program was developed. And also if there's a file name, you can comment it. But comment is normally a note of explanation within the program. And this will be ignored by the Python interpreter. And in Python, a comment always starts with the pound sign. So anything after the pound sign, when you compile the program, compiler will ignore it. We also have end line comment. This appears at the end of the line of the code, and that's the end line comment. So next is the variable. What is a variable? A variable is normally a memory space in our computer. So for example, if I write a program to find the sum of two numbers, I need to store those two numbers in some place in my computer system, maybe memory. So what I will do is that I will declare two variables and I will store the data. So variable is normally used as a storage place. Now, when we declare variable, we can give it a data type, which means what type of data can be stored in that variable. Python normally is very, very user-friendly when it comes to data type of a variables. I can declare a variable without specify the data type. By any value I put in, it will assume that is the data type. Unlike Java, when I declare a variable, I have to specify the data type of the variable. In Python, we don't need to. So we can see the format here. We have a variable equal to expression. We didn't start with the data type. Example will be age. Assignment equal sign is called assignment operator. So here we are saying that we are assigning 29 to the variable name age. Now, when you have two equal sign, then it's called equality. So we may again write a code, hopefully by next 2 lectures. We may do a lab work and we'll see how all this concept plays in a lab work. So in the assignment statement, variable receiving value must be on the left side, and the variable can be passed as an argument to the function. So the variable name will be on the left side, and the value that we assign to the variable will be on the right. Between the left and the right, we have the assignment operator. Now, we have some rules for naming variables, not only variables, but all the identifiers like functions, classes, etc. So the rules for naming variables in Python is that variable name cannot be a Python keyword. A Python keyword are the words that Python understood. For example, I can't declare a variable and name it print with P as a lowercase. P is a lowercase. Now, if P is uppercase, I can use it because uppercase P print, Python don't understand. So a keyword is any words that understood by Python. For example, I cannot declare a variable and name it for, because Python understands that for means for loop or while. So first of all, we make sure we are not using the keyword, or we also use the term reserved word. And also the variable name cannot contain space. So there's no space in the variable name. The first character must be a letter or underscore. We cannot start with a digit. And the first character may use letters, digit, or underscores. So we can see that based on this rule means a variable name or any identifier's name in Python consists of letters, digits, and the only symbol we have is the underscore. Also, variable names are case and case sensitive means uppercase and lowercase are different. That's why I said I can declare variable name it print with P as uppercase, but print with P as a lowercase is a function that Python understands. So displaying multiple items with the print function, yes, it's possible we can display as many informations as we want with a print function. So Python allows one to display multiple items with a single cop to print. Items are separated by commas when passed as argument, and also argument display in order they are passed to the function. Items are also automatically separated by a space when displayed on the screen. So variables also can reference different values while program is running. And we have something we call the garbage collection. This is the removal of values that are no longer referenced by the variables and need to be carried out by the Python interpreter. Also, a variable can refer to item of any type. The data type can be any type. We have the numeric data types, literals, and also string data type. So the categorized value in memory, int is for integer, float for real number. String str used for storing strings in memory. Also here, number written in a program, we say no decimal point considered int, otherwise considered float. We can also reassign a variable to a different type. So for example, I can have a variable name, let's say X, and we assign into it. Later we can change it to float X. Now, reading input from a keyboard, we always use a function named input. Input is a built-in function in the Python library system. So example is given here. Input, whatever I want to explain, when user enter the input, it will go to the variable name variable. So input function always return a string. So anytime we enter a value input function, the data type will be string. So sometimes if we are going to do calculation, we have to convert into either int or float. So performing calculations, in Python, we have almost the same mathematical expression as any programming language. The difference is that in Python, we have two types of division. We have a single /, and that perform again floating point division. So for example, if I said 5, only one / divided by 2, the answer will be 2.5. Now, if I say 5, 2 front slash and 2, we're going to get 2.5. I mean, sorry, 2. The single 5, single / 2 will give me 2.5 because it's float point division. When you use a 2 / you are doing integer, which means we are going to ignore the remainder. So 7 divided by 3, the remainder is 1. The answer is 3. But if I use 2 / it will give me 3. But if I use 1 / it will give me 3 point some value, maybe 3.2 or so. So these are the operator precedences, same as most programming language and also in mathematics. Operations, we always start with the parentheses first. Then the next will be the exponential, multiplication, division, then modulus. Then we do the last step, addition, subtraction. The exponent operator and the remainder operator. So we can see how the exponent operator looks like. 2 star means x to the power y. Then the modulus operator, which is the percent. If I say 4 modulus 2, it means 0. Because 4 divided by 2 is 2 remainder 0. Now 5 divided by 2 is 1. Why? Because 5 divided by 2, 5 modulus 2 is 1. The reason why 5 modulus 2 is 1, because 5 divided by 2 is 2 remainder 1. And modulus is for remainder. So converting math formulas to programming statements, here we said operators normally required for any mathematical operation. The operators can be addition, subtraction, multiplication, division. Now, when converting mathematical expression to programming statement, first thing we need to do, we may need to add multiplication operators. Also, may need to insert parentheses. Sometimes we may have a mixed type expression and a data type convention. So data type resulting from math operation depends on data types of the operands. The operands are the values that we are either adding or subtracting. So 2 int values will result an int. 2 float values will result a float. Now, if I have a float and int together, int temporarily converted to float, and result of the operation will be in float. Now we have 2 types of conversion, float to int, cause the truncation of the fractional part, because if I have a fraction 3.5 and I want to change it to float, I can make it 3. We can also break a long statement into a multiple lines. So when I write var1 times 2 plus var2 times 3 plus, when I want to move to the next line, I'll have to put a backward slash or backslash. Then we get var3 times 4 plus var4 times 5. So multiple line long statement into multiple lines. Here we say any part of a statement that is enclosed in parentheses can be broken without the line continuation character. So we can see how we broke this. Monday, we go Tuesday, the rest. So a print function normally will display line of output, a new line at the end of the printed data. Now we say special argument n equal to delimiter causes print to print delimiter at the end of the data instead of new line character. We may discuss this in the lab work. Also, the print function uses space as item separator. Also, special characters appear in the string literal. For example, we have the backslash. So here we say when plus operator used on two strings in performs, you can perform string concatenation. So for example, I can use the plus to add two values, but now when I have one string and one value, it will join the two together. Or if I have two strings, it will join the two strings together. And this is called escape sequence. So we have again backslash. Backslash n means we move to a new line. Backslash t means we tap our key. Also, we can use the floating format function. We can use the format function to basically format the display of numbers on the screen. So two arguments, we may have numeric value to be formatted or format specifiers, and it always returns a string containing the formatted number. So we use the percent symbol. So the percent symbol can be used in a format string or format function to format number as a percent. Now to format an integer using format function, we can use D as the type designator and do not specify precision. Also, we have something called the magic number. You can see a value here, amount equal to balance times 0.069. 0.069, we don't know what it is, whether it's an interest rate or some other thing, we don't know. So it's a magic number. And the magic number is an unexplained numeric value that appears in the program code. So for example, what's the value of 0.069? So problem with magic numbers, here we say it's very difficult to determine the purpose of the number. Also, if the magic number is used in multiple places in a program, it can take a lot of effort to change the number in each location. So this is the reason why we always declare variable constant. So if I need to change the value, I'll just go to the place I declare the variable as constant and change it, and it will affect the whole program where I change the value or where we have the specific variable. So that comes with a name constant variable. So here they say we should use name constant instead of magic numbers. So if I know my interest rate is 0.069, I will use 0.069 in my formula, because anytime the interest rate change, I have to go to my code looking for everywhere that I'm using 0.069. So the best thing is to declare variable interest rate as a constant and assign 0.069. So anytime I'm going to use the variable name in my code. So in case the percentage change, then I'll come here and just change it, and it will affect everywhere that I use interest rate variable. So advantage of using the name constant, here we say name constant make code self-explanatory or self-documenting. The name constants also make code easier to maintain because we have less code. And then value assigned to the constant, and new value takes effect everywhere the constant is used. So in summary, in these lectures, again, we study about the program development cycle. As we said earlier, it's a requirement, step 1, design, step 2, implement a code, step 3, testing, 4, and 5, put the code or the software into operations. So those are the software development life cycle. We also talk in which ways we can receive input. Normally, we can receive input using the input function. We can print an output using the print function. We can declare variable. We saw all the data type. So this will be the conclusion of my second lectures in Python. Thank you.